So we are looking at different types of triangles today. Triangles can be classified by their sides, and the first one is called equilateral. Just the term equa means what? Equal. Equilateral means like the sides. So an equilateral triangle means that all three sides are the same length, right? Now to show that, you guys with earbuds in, you should get them out. To show that, generally they put like a little mark. Okay, come on, what's going on?
Oh yeah, that line, right?
Right? They put like a little line. So when you see that kind of thing, that means they're all the same. That's how you show that. Okay? All three sides are the same. Now, if they're all the same, it also means that all of the angles are exactly 60 degrees. So each one of these guys here is 60. Do you guys know the total of all the angles in a triangle? Remember? Not 90. 180. Right? All angles in a triangle. All angles in a triangle add up to 180. So that's kind of a rule that you're going to need to know. All angles in a triangle add up to 180. Okay? Equilateral means all sides the same. This is going to take a while to go through today. Okay, now the second, all angles in a triangle add up to 180. So like if you know two of them, you can figure out the third one, right? Okay, so the second kind of triangle is called isosceles. It's a fun word to say, isosceles. Not isosceles. That means that two sides are the same length. So where would I put my little pen marks here?
A, C, and B.
Exactly, right? You can see those guys there. Those guys are the same. Okay, now in an isosceles triangle, there are two angles the same and they are opposite the same sides. So the rule is an isosceles triangle, that kind of thing. Angles opposite equal sides are equal. Okay, now they sometimes show that. Let's get rid of those guys here. They sometimes show that with just like a dot. Not always, but that kind of thing indicates that those are the same. Do we know how much they are? Like, can you say they're 50 or 60 or 70? You can't, right? But if you knew this one here, like say like you knew this one was 30. What would these ones, Josh? If this one here is 30, remember they add up to 180, right? So these two down here would have to add up to, if all three add up to 180, and that one's 30, these two would add up to, if there's a total of 180, and the top one is 30, that means that the bottom two add up to 150. Divide that by 2, you're right. So they would be each, divide by 2, they'd be each 75. Right? Okay. The last kind of triangle we're looking at is called scalene. All sides are different, all angles are different. It's all whack. All different, right? Like everyday teaching, it's all different. Never know what you're going to get. It's like a box of chocolates. Forrest Gump movie. Anyone listening out there? Hello. Is this microphone on? Huh? Oh, sorry. Okay. Now, we can also classify triangles by their angles. Acute angles, they're not like baby triangles or anything like that, or acute triangles, right? A little joke there. All angles are less than 90. So, for example, this one here.
Did we do anything on the others?
Did we do anything? Yeah, I wrote stuff down. Oh, on the scalene?
Yeah.
No, they're all different. So, If all the angles are less than 90, then we say that this triangle is acute. Right? The second kind of triangle is a right triangle, where the largest angle is exactly 90.
Yes.
And we always show, should be on the next page, yeah. Now, if you haven't flipped your page, you need to flip your page.
Virtual, man.
How do we show a right triangle? Or how do you show a right angle?
You do the square.
Little square, right? So it's in there in blue, but I'm going to put it in red here, right? The little square indicates a right triangle, right? Is that a German word?
Yeah.
Does it? Yeah. Okay. Book's right here before you sit down. The last type of triangle is called obtuse, and it means that the largest angle is more than 90. So it's kind of like leaning over like this kind of thing, right? Like kind of, you know what I mean? Like open, falling down triangle. Obtuse. Okay. Page 3. Josh. Page 3. Lane, finish that conversation up. Okay, second kind of thing is what we call a quadrilateral. What is a quad, right? Four wheel, right? They used to sell them those little vehicles. They used to have trikes, and then they found out that they were deadly and a little unstable, right? So now they moved to four wheel
They're fun.
quad.
They are fun.
Yeah.
That's why the other day I was working with the 4 wheel, you know?
Yeah? You were ripping with the four wheel. Okay. A quadrilateral is any shape with four sides, and you already know some. You were introduced probably in kindergarten to the square and the rectangle. But there are many different types of quadrilaterals. You know some others? Here they are. On the next page. What? Okay, so let's go down the left-hand side. Let's start with the left-hand side. So we're talking about quadrilaterals, and they can be like categorized or families kind of thing, right? So the parallelogram over here on the left, two pairs of parallel sides. Now, do you guys know the little mark, the little symbol for parallel? I don't know what grade you might have been shown that in. You know, Kelsey?
No.
You do, but you can't remember. So to show parallel, I'm in red, you kind of do like a little arrow, right? You don't remember that?
What's the other one that gets you the equal sign, or is it that one?
Sometimes they do that. Yeah, I think. Well, hang on here. Maybe let me just check that. Okay, so let's go back to this. So let's get rid of those guys, right? Doesn't like that. Yeah, so the little. Now we got two pairs of. How can I show that? Like these guys are parallel here, but these ones, the sides are parallel as well. So what you do is you put like a double arrow. You indicate that the double arrow ones are parallel, and the single arrow ones are parallel to each other. What does parallel mean, Josh? Remember? What do you mean by even? No, not necessarily. In this case, they are, but that's not what parallel means. They never touch. They go straight line forever. They never touch. The most classic example is train tracks. Right? Train tracks go forever, never touch. Right? Lines on a basketball court would be parallel, never touch. Football field, same thing, right? They go forever, and they never get closer together or farther apart. Okay, so a parallelogram can be classified, there's two types of parallelograms, right? Because parallelogram doesn't need to be sort of tilted over, it could be straight up and down. And if it's straight up and down, then that's called the rectangle. Right? So a rectangle has these double parallel lines, but it's also, all the angles are what? 90 degrees. Is that what you're trying to say, right? Is that what you're trying to say? 90 degrees?
Yes, sir.
Oh, okay. Now a rhombus is like a parallelogram, except Oh, that's a double. Except that all sides are the same length, so we're going to show that with the marks like this, right? That indicates that they're all the same. Now it's becoming like a hairy rhombus, right? So the arrows indicate parallel, the little lines indicate the same length. And a square is like a rhombus. Oh, geez. Not Harambe, no. Square is like that, and also right triangles.
Ain't that right, Mr. Bennett?
What's that?
We came from a monkey?
We came from a monkey. What do you mean?
Hey man, I don't want to argue.
I'm not going to argue with you right now. Okay, another kind of quadrilateral is a kite. Kites really don't have any special characteristics, but they do look cool, and they have these kind of things which we're going to talk about tomorrow or the next day called diagonals.
You want me to make you a kite?
No. But you could go fly one for me. I know. It was just for you.
Thanks.
Now a trapezoid has one pair of parallel sides. Oh, it looks like someone's already left the little blue mark on there, right? So see how those are parallel, but the other two, not parallel. That's called a trapezoid. Then there's an this hurts my head. Isosceles trapezoid. Legs are the same length. Really? So these are parallel, and then all the sides are the same length. And a right trapezoid, two right angles. Okay, let's get ridiculous. Now they're just making stuff up. Is all math just made up?
Yes.
I believe it is.
It is. It's all made up. Well, it's like a set of rules, a set of laws almost that we all agree to.
When are you gonna end up doing this in the middle of the job?
No, this stuff, Robert. You're not gonna. Yeah, you're right.
Mr. Van, if you think about it, everything is made up.
I don't know. Lots of stuff is made up. Yeah. Okay, so why triangles, Robert? Well, it turns out triangles are important in construction and design. They're strong and they do not easily deform or change shape. Like they're rigid, right? Hey? Yeah, like bridges have that, right? Or like think about like cell phone towers, right? Okay. Triangles are the simplest polygon, only three sides. The quadrilaterals are used in many construction applications. Many quadrilaterals have parallel sides and 90-degree angles. Why is it important? Well, because we probably want to keep things apart. We never want them to touch. Right? Quadrilaterals can also be easily divided into two triangles, so they're important. When you're doing a patio, you want to make sure it's square. Right? So it doesn't sort of look all weird. It's visually pleasing. Blah, 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 blah. Okay, here's a rule you need to know. The sum of the measures of the interior angles of a polygon with, and I'm going to put little air quotes here, n sides is n minus 2 times 180. What? Exactly. Okay, so if it's a three-sided figure, which we commonly know as a triangle, our n is equal to 3, right? Our n is equal to 3, so 3 minus 2 is times 180. The angles in a triangle add up to 180. If it's a quadrilateral, a four-sided figure, Josh, the n is 4. 4 minus 2 is 2. Are you with me writing, or are you on your phone?
I'm with you.
And if n is 4, 4 minus 2 is 2. 2 times 180? 360. The sum of all the angles in a square or rectangle is 360, a quadrilateral. A pentagon. Where do you see a pentagon? No. Huh? Well, there's one in Washington, D.C., right? That's where the FBI has their big office. I don't know why it's a pentagon.
Why is it in the middle of like?
Washington?
Yeah.
Do you think that when we get close to the exam that I should maybe work on a cheat sheet with you guys together
Yeah.
and not leave you to your own?
Yeah.
Okay.
Please.
Thank you.
You're welcome. I look forward to doing that. Okay, blah, 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 blah. Okay, so for example, do you guys have this picture?
Yeah.
Okay, so this is how many sides? 1, 2, 3. This is 4 sides, right? So my n is 4. My n. Right? So the rule is n minus 2 times 180. So what's the sum of all the angles here? It's going to be 4 minus 2 times 180. 4 minus 2 is 2 times 180. This is a four-sided figure. It has 360 degrees. Now you could just do the formula, or you could just have this handy-dandy chart, which is a four-sided figure, 360. Okay? So, the question is, what is x? How many degrees is x?
We don't know.
Well, we don't, but we know that all of those angles add up to,
20.
no,
360.
it's right there, man, 360. Josh, are you with me? Are you calculating? Okay. So, hey,
What is that say? Subtract 2 and what's that side?
4 minus 2?
No.
Oh,
N.
n
What's
Yeah.
that for side, like after that?
times 180?
Yeah.
Oh, it's just like a multiply. I put a star. Sorry.
Well, usually star also makes.
Yeah.
I put star too, so
I copied that one.
Times. Sorry.
Times.
So what is x? So we're going to take 94 plus 107 plus 93 is 294. 360 minus 294 is 66 degrees. X is 66 degrees. So you might see a question like that on the exam. Have you ever seen a question like that in the exam? Say again, right?
How many page exam do we have?
I don't know how many pages it is. Kelsey could count if she wants.
Who's giving us the exam? You?
I'll be in the room, yeah.
You're making the exam?
I am not making up the exam. The province of Manitoba makes up the exam. I told you that at the start, right? I did. If you were here and you were listening, you would have heard it. Okay, so how many sides here? 4 again. We know that it's going to add up to 360, right? We can just go 96, 106, plus 57. And 59. 360 minus 259 should be 101, I think, right? Did I do my math right? Yes, I did. 101 degrees. Okay, those are kind of easy. Oh, are you allowed to bring drinks? Yes, you can bring a drink.
What about candies?
Yeah.
What about McDonald's? Big meal.
You know, that's just going to make everyone hungry, right?
That's the point. Coffee's good enough.
You can bring coffee if that's what helps you. Okay, yeah. Oh, yeah, I wanted to show you this. Okay, a parallelogram has some additional properties. Opposite angles are congruent. There's a word that you may not have known already. Congruent. Blaine, do you know what congruent means? No? Congruent means equal in measure. They're the same. Congruent, Chris. Equal. Congruent. As you drag any vertex in the parallelogram above, notice that the opposite angles are congruent. And consecutive angles are supplementary. Ooh, I hate that word. Consecutive angles are supplementary. What they mean that is this. Consecutive means like beside each other, right? So like, let me see if I can do it here. A and B are consecutive. How much do they add up to? 180. What about these two? 180. Is that true always? 110 and 70. 180. 120. 160. 180. So the angles that are beside each other always add up to 180. That's what they mean. Okay? Let's write this in real English. Angles beside each other add up to 180. Angles beside each other add up to 180.
Oh my god.
You'll never forget that. Not arseholes. It's pretty close. Angles beside each other add up to 180. Okay. These are actual provincial exam questions. I stole this from a provincial exam. I'm allowed to. It wasn't stealing. I'm allowed to. The following shape is a parallelogram. State the measure of A, of angle A. Where's angle A?
Right there.
Right there. It's a Canadian angle. A?
Canadian name? Oh. I got it.
The German kid got it, yeah.
Like what? The Canadian A?
What is the value of A?
Canadian A.
Remember we said that angles beside one another, Lane, you've been on your phone way too much, man. Who you have a conversation with is so important.
Canadian A.
245.
How'd you get that?
Because it's subtracted 360 from 150.
No, but they don't. Remember consecutive angles add up to?
180.
180.
So that
Angles beside each other add up to 180. So 180 minus 115.
65.
65. Now they might trick you. They might ask you for side. Oh, I guess that'd be consecutive as well, right?
Yeah.
So if this one would be 65, that one would be 65, that one would be 115, right? 9, 10, 16, 18, 76, very well. No, 66. Gotcha. 60.
76. Come on, I told you Espanol, man.
I know. I forgot. Hablas Espanol. Right? You and I should just talk about other people in Espanol. What do you think?
Get out of here. Just like, you guys get out of here. Go somewhere else.
Okay. This one's a little bit harder. Let's have a closer look.
Oh, there's 3 triangles.
This one, yeah, this one's got a little bit harder.
Actually 4.
Okay, let's just read. We may want to reread. I'm going to put my pencil down. Leslie is designing a new quilt whose pattern consists of 1 equilateral triangle and 2 congruent obtuse triangles. Okay, right away the language is blah.
Yes,
State the measure of angle A. So they're asking us for angle A. They want to know what's angle A. Okay, well, what else do we know here? We have a triangle.
We have more than one.
We have a triangle, and we know that the sum of all the angles in the triangle add up to 180, right? I got this one. I'm trying to find A. Will this one here, this 100 and this A, will they add up to 180? I thought they add up to 180. Like, didn't they add up to 180 over here? That was only for what? Parallelogram. This is not a parallelogram. This is a triangle.
Would it be 40 then? Or no?
No.
Why would
Like, it wouldn't be, like, you thinking 40 and 40? Because this
Well,
ain't,
it-
this,
well,
60.
Because the bottom is 40, and then 100.
but that's not an angle, that's 40 centimeters.
But the
Right.
other side has 60.
This one, the other one has 60, you're right.
So doesn't it reflect on the other? I already
Okay.
said 60.
So just, let's hold on here. I do see this. I see, in this triangle, I see those little marks. So what does that mean?
Okay.
It means that that triangle in the middle is an equilateral triangle, which means all the sides are the same and all of the angles are, Josh, put the phone away because this is important. This is from an exam. An equilateral triangle has all angles that are 60. So in other words, all of these little guys in here are
60.
60. Right? Okay, that's valuable. They're all 60. Now, I don't think I've told you this yet, but a line is really just an angle that's like opened all the way up, right? Like a book. Right? Here's an angle, like 30, 40, 50, 60, 90 degrees. When I make the book flat, what's the angle? Straight line. How much? You want to know? 180. Right? A straight line is 180 degrees. Right? And that's something that you should probably have on your cheat sheet. A straight line is 180 degrees. And we can use that because I got 60, 60. What's 60 plus 60? 120. So what does this one here have to be? No. These two here add up to 120. This one here has to be another 60, right? 60 plus 60 plus 60 is 180. Now I got two triangles. I got a triangle, I got 100. I got two angles in my triangle. I got 100 and I got 60. 160. This one A has to be 20. Bingo. Angle A must be 180 minus 160 or 20 degrees. Boom, chicken soup.
Maybe it's the washroom?
No.
After?
After.
Yes. I didn't say right now.
No, of course not. How much we got left? One more. Okay, we got one. Okay.
Oh, actually, one more.
Okay. Okay, so this is part B of the same question. This is a review, and I thought, well, I'm going to leave it in there. I know. Choose the equation that allows you to solve for y. Choose the equation that allows you to solve for y. Where's y? Y is right there.
Why?
I don't know.
I don't know.
Why? I don't know. Okay, so what do we know in this triangle?
I don't know.
I know I got a side.
About 40.
I got a side and I got two angles, right? Oh, what do I do? I remember this. The angle here is opposite the side. Oh, and this angle is opposite that side. I got like angle, side, angle, side. That's sine law, isn't it?
Well, they use
No, they don't use, oh, they do have two sine laws. So it's not the cosine.
Take a look at the side also.
I'm confused?
I am a little confused. Okay, well, hang on here. Well, y is opposite, should be sine 60, should it not? This one is right. This side of it is right. But that's not, that should be sine 60.
That's not correct.
How did they get 13.89?
They're using, instead of, we need an angle there, and they're suggesting that it's a side, so sine.
Yeah.
Side,
So maybe, you know what?
side.
Those ones don't work either. Maybe I'm wrong.
Don't,
Maybe one of these two is going to work. Okay, well, let me just see here. Y squared equals... how do they... Oh, I see. This side... These are hard. This side here is 13.89. Remember, that's an equilateral triangle. So this side right here, I'm going to zoom in.
Oh, they're all.
Right? You're just going to guess? Is that what I heard someone say? Lay. This is 13.89, so this side here is also 13.88. So I really have, I got two sides, and I got an angle. I could use, Josh, you're on your phone again. Elvis, take his phone away. Serious, Elvis, take his phone away.
Elvis.
Take his phone away. Put it over there. Yeah. Yeah. Thank you, Elvis. So it is going to be, I can use cosine law, right? So I got the two sides and the angle. So which one is it?
What do I say when they...
Don't reply. Josh, who are you talking to? Is it your mom?
I was looking at an update. Tavares is out of world.
Okay. We can do that at break.
Yeah, sorry.
So it's going to be one of these. I got the two sides. Oh, this is right. Remember, it's two sides and the angle between them. Oh, it's the 61, right? It's that one.
Yeah. 60.
It's that one.
yeah.
It's the 60.
It's the 60, yeah.
6-1.
Yeah. The 61. 60 equation. Okay, one last one. Oh, you guys should be able to do this.
No.
No? Okay. The angle at the top of the following isosceles triangle is 82. Calculate the measure of one of the base angles. So they're saying, what is that angle there? Isosceles triangle, what did we learn about an isosceles triangle? The angles at the bottom are the same, right? They're both the same. And if they add up to 180, yeah, 180 minus 82 is 98. And then divide that by 2 because they're equal. 98 divided by 2 is 49. That's probably 1 mark.
Done? You still watching now?
I want to go back to this question quick here.
Oh.
When you're faced with a multiple choice question like that, should you look for answers that are obviously not right? Like if you are forced to guess, should you at least look at ones that are clearly not right? Yes. If you're going to guess, try to reduce your chances. Okay. I'm